Education expert John Dewey once said, "If you give the pupils something to do, not something to learn, and the doing is of such a nature as to demand thinking, learning naturally results."
Welcome to the A&P Professor, a few minutes to focus on teaching human anatomy and physiology with host Kevin Patton.
In this episode, I have updates on the shape of the heart and the role of exosomes in cancer, then a discussion of ways to amplify learning in our course. Don't you hate it when people use jargon and you don't know what it means? And they're halfway through their story before it dawns on you what they're talking about? Or maybe you have to stop them and say, "What is that LMS acronym you keep talking about?" Of course, that means Learning Management System. And so I might be off on a rant because I'm frustrated about some aspect of my LMS that I'm using, and you don't know what it is that's frustrating me so much because you don't know what an LMS is. And, well, of course, you all know what an LMS is, but somebody else might not. And I realized recently that I've been guilty of that in the various episodes of my podcast. I've been talking about two things that you may not understand what I'm talking about, and they are the episode page and the show notes. I will frequently, especially at the end of the episode, say you can find links to various resources related to these segments in the show notes or the episode page. And what is that? Where is it? How do I get there? What in the world is that? Well, there are different places where you might be finding this episode to listen to it. You might be on the approfessor.org website. And if you're on a page that is dedicated to this episode, then that's what I call the episode page. And if you scroll down below the player, you'll see the show notes. So the show notes are on the episode page. And show notes is a podcasting term that is used to talk about any notes that are provided along with the show or with the episode. So we call those show notes. And for this podcast and many podcasts, it's usually a bunch of links that are going to link you to the resources or the original sources on which I'm basing the information I'm giving you in the various segments of this podcast episode. So when I say, look at the show notes, that's what I'm referring to. Now, there are other places you can find this. It depends on where you're listening, what's most convenient for you. You might be listening in a podcast app. Maybe it's the A&P Professor app, which you can download for free in your device's app store. Or it could be a generic podcast app where you can listen to a lot of different podcasts like Apple Podcast app or Google Podcasts app or Overcast or Stitcher or there's a whole bunch of them. Or you might be listening on a radio platform like Pandora, for example, or Spotify, or Deezer, or one of the other so-called radio apps or radio platforms. And in any of those, there is likely to be some information, a little mini page of information that you can see on the player if you have the player visible on your device. You should be able to swipe up or down or around or something, and you'll see the show notes. And sometimes the hyperlinks are live and ready to go, and you can just click on one and go to an article from the journal Nature or an article from Science News or a previous episode, the episode page for a previous episode, or some other link that I have there. There are some of those platforms, especially the radio-based platforms, but some other podcast platforms where you can't really click on it from there. So in that case, you're going to want to go to the episode page at the approfessor.org where all the links are live. And you can do that from your browser on your smartphone or other device if you want to do that. In the more recent episodes, I've taken to, instead of just hyperlinking the title of an external resource, I will give you the URL and hyperlink the URL. So if the hyperlink is not live and clickable, then at least you can copy and paste it into your browser, and that makes it a little bit easier for you. I hope it's easier for you. So, okay, just a little bit of housekeeping to start off the episode to clarify what I mean by show notes and episode page, where you're going to find links to links that are related to all of the topics we're talking about in the segments of this episode. Marketing support for this podcast is provided by HAPS, the Human Anatomy and Physiology Society, promoting excellence in the teaching of human anatomy and physiology for over 30 years. I've been a member of HAPS for a long time, and there are many resources available to members that help us in our teaching. And one of my favorites, I have a lot of favorites, but one of my favorites is the HAPS blog. And a recent posting in the HAPS blog really caught my attention because it's just so brilliant. Our member, Carol Britson, did a little piece here about how to clean the plastic models in our labs. She had run into a situation where over a period of years, a lot of grime had built up on the plastic models, and the usual soaps and detergents she was trying to use really didn't do the whole job. And she found a way, and this is brilliant, she found a way to use denture cleaning materials to clean off her plastic models. And I have a link in the show notes and episode page. I recommend you take a look at it. And don't go doing this yourself without looking at her article, because she walks you through the steps of how to do it, and she points out some possible pitfalls. So before you run into a pitfall, that is, before you fall into a pit, you want to read her article. But do that. And then while you're there at the HAPS blog, check out the other entries in the HAPS blog. And while you're there, then why don't you start looking around some of the other resources that are available to our members. And if you want to visit HAPS, just go to theapprofessor.org/HAPS. That's HAPS. When I talk about cells in my anatomy and physiology course, that includes a survey of the major organelles, just like you do. And when I'm done with that, I emphasize to my students that these organelles that we've just discussed are going to be important players, important characters in the story that I'm going to tell over the course of these 2 semesters, the story of the human body. But there are other organelles that have been discovered, and there are some yet to be discovered. And it's important that they know that, even though we're not going to be covering the other kinds of organelles in our course, they may encounter them in a later course or in their clinical activities or research activities, depending on their career path. And one of the examples I often give are exosomes. Exosomes are extracellular vesicles. That is, vesicles that are pinched off of a cell and contain substances from that cell, and they'll travel in the extracellular environment, the extracellular matrix, and probably get picked up by another cell. And that second cell is now going to have substances that came from the first cell. And those substances may act as a signal or have some kind of effect in the second cell. And we're working out a lot of those stories of the different kinds of exosomes there are, different kinds of extracellular vesicles, and what roles they play. And that's why I'm bringing it up right now, because I just ran across an interesting story about the possible role of exosomes in cancer, particularly in brain cancer. We know that brain cancers can be very, very dangerous, as most cancers have the ability to be very dangerous. And we know that a lot of brain cancers actually started out in another tissue. It's not all that uncommon for lung cancer to spread to the brain, or breast cancer, or melanoma to start secondary tumors, to metastasize to the brain. And so how is that working? Because you have the blood-brain barrier there. How are things getting past the blood-brain barrier? And so they were looking at the role of exosomes in the exosomes being released by tumor cells, going into the little microenvironment, the extracellular environment around that primary tumor. And they were seeing that those exosomes, and this work has been done before, those exosomes may be signaling the cells, the surrounding cells, to create an environment there that is more conducive to tumor cells. So that's going to enhance the ability of that tumor to grow. which we know is a characteristic of malignant tumors anyway. So it's going to grow, and those factors may also enhance the ability to metastasize, to get into the bloodstream and move to some other area of tissue, maybe nearby or maybe far away, like in the brain. But when a metastatic cell from a primary tumor gets to the brain, then how's it going to get across the blood-brain barrier? And how are those exosomes that are being released from the cancerous tissue, from the malignant tissue, that are making the environment hospitable for that metastasized cell, how are those EVs going to get across the blood-brain barrier? EV is for extracellular vesicle. We know that the exosomes involved are too big to get across the blood-brain barrier, or at least the normal measurements of particle size that we see that are being blocked or not blocked by the blood-brain barrier. And they should be blocked, but they're not. They're getting through, and they're making it, the brain, local areas of the brain, more hospitable to developing a cancerous tumor. So this study was to see, well, how can that work? And so what they found was that the blood-brain barrier, the first thing you hit if you're trying to get out of the blood vessel, is the endothelial cells that form the wall of the capillary. And normally when something tries to get through, they'll tighten up, and there'll be some signaling between the endothelial cells and some of the surrounding cells called pericytes, Pericytes, and the feet, the flattened out feet of the astrocytes, a kind of glial cell. And we know that there's like this triple layer that they have to get through, and that it's hard for large particles to get through, if not impossible. And what happens is those exosomes, they hit the endothelial cell, and they induce the endothelial cell to do something called transcytosis, which is a process that we see from time to time in the body, where a vesicle is taken up by a cell and pushed through to the other side, pops out the other side. And that's what these particular cancer-associated vesicles are doing, is they're sort of tricking the blood-brain barrier. And not only that, once they're through the endothelial cells and they get through the blood-brain barrier, they're going to go to the astrocytes and get picked up by the astrocytes, and the astrocytes are going to help change the environment in that local area, so it's more conducive to not only metastasis, that is the moving in of cancer cells, but the environment to grow cancer cells. They're going to make it so that it's better for cancer cells than normal cells. At least that's what we think. This is a very preliminary story, but it's interesting that these organelles, the exosomes, have a role in that. And now that we know that, we might be able to stop things. And not only that, we might be able to hijack that system and use these exosomes to deliver anti-cancer agents or some factors that's going to reduce the success of those cancer cells. So I have links in the show notes and episode page if you want to learn more about that. A searchable transcript and a captioned audiogram of this episode are funded by AAA, the American Association for Anatomy. Did you know that if you're already a HAPS member, you can sign up with a greatly reduced membership dues in AAA? Check it out at anatomy.org. We know by doing research that the human body adapts to different levels of activity in our life, and that we can actually change the structure and function of our body if we change the kinds and amounts of physical activity that we do. And I recently ran across a story of a study that looked at the effects of these kinds of activities that we do in our life in the heart, specifically in the shape of the heart, and even more specifically in the left ventricle. And the subjects that they looked at were adult men, 160 of them, and they were from 4 different groups. One group were long-distance runners. Another group were sedentary adults. Another group were highly trained football linemen. And another group were a particular group of Native American farmers that were renowned for their running ability. And then they added in a 5th group, which were not human adult males, but they were 43 adult male chimpanzees, because they were kind of looking at this from the evolutionary perspective of what is our heart built for and what is the range of adaptability that we have evolved as humans. And so I don't think it's too surprising, but it's interesting anyway to look at what the results are. And they found that the endurance runners and the farmers, remember these are farmers that are well known for their running ability, their left ventricles tended to have sort of elongated ventricles with thinner walls than maybe average. And when you think about it, when you have, a thin flexible wall and it's elongated, that means that you can pump a lot of blood with every stroke, every beat of the heart. And so you're going to have a good stroke volume. And when you're doing endurance activity, you're not going to have a lot of blood pressure resistance to push against. So that thin wall, it's going to work. It's going to not only be flexible enough to fill greatly, but you don't have a large pressure gradient to overcome as you would if you were doing resistance activity, that is high intensity resistance activity. So then they looked at the linemen that were doing training that really emphasized that short bursts of high intensity activity, and they ended up having the shortest and thickest walled ventricles. So they weren't elongated and they were thicker walled. And that makes sense because what's more important there is not the total volume of blood flow per minute or hour or whatever, but what's more important, or at least what is a big factor, is pushing against the great resistance that is going to be built up in the peripheral areas of the cardiovascular system as you're doing this high-intensity activity. So, yeah, but worked out as we would expect it to work out. They also found that the sedentary humans, they had relatively short, thick-walled hearts as well, or left ventricles at least. And that kind of makes sense because they're not having to elongate it and so on to adapt to endurance activity. They're not doing any endurance activity. They're doing short bursts to the kitchen to get another beer and another bag of chips, I guess. And the chimps, well, they're kind of the same way. Their main activities are, just kind of foraging around lazily, sitting around, doing nothing, and every once in a while getting up and fighting or climbing, climb up a tree and then take a nap, and then climb down the tree and walk around a little bit and gather some things. This all kind of works out. If you want to read through it, I have a couple of different links to this story in the show notes in the episode page. The free distribution of this podcast is sponsored by the Master of Science in Human Anatomy and Physiology instruction, the HAPI degree. I'm on the faculty of this program, so I know the incredible value it is for A&P teachers. Are you looking to power up your game in teaching A&P? Well, check out this online graduate program at nycc.edu/HAPI. That's HAPI. Or click the link in the show notes or episode page. I want to spend a few minutes today talking about how we can amplify learning in our A&P course. And what do I mean by that, amplify learning? Well, you know what the word amplify means? It means make something louder, make it bigger, make it more. So I'm talking about making learning more in our course. That is, get students to learn maybe more concepts, maybe a larger number of concepts, but I'm really focusing on learning better. That is, learning more deeply, learning more clearly what the connections are between the different concepts that they're learning, putting it all into their long-term memory so they can retrieve it later and apply it and solve problems with it. So you have your own idea, you put into your own words what learning is, and I'm saying that whatever that is in your mind, we can always do better. I know we can do better. I'm pretty sure we can do better. I don't think I'm that much different than all of you out there in the classroom teaching. Well, for the more than 30 years that I've been in the classroom, I have frequently run across new ideas that have been shared by colleagues that I've seen, observed in classrooms that I've visited, that I've read about in the literature and so on. that I've tried out and maybe adapted or maybe tweaked or whatever, and maybe come up with some new variation on it. And so over the years, I can really see that the learning in my courses has gotten bigger. It's been amplified. Why? Because I've been employing some of these ideas. And I'm not saying that I've arrived, that I've gotten to the point where I'm satisfied. I don't think I'm ever going to be satisfied. I hope I'm never satisfied, because that'll kind of take the fun out of it. But, I'm approaching this mythical perfection that I think a lot of us strive for in our teaching. Like, how can I do this better next semester? And this is why, as I've mentioned in previous episodes, why it's important to do mid-semester and end of semester and end of year debriefings to kind of reflect on that year and what worked, what didn't work, what things have I heard about over this year that I can try next time around. So I'm going to sort of organize this discussion and just hit on a few brief ideas. Again, some of them you've heard in one way or another before, but I'm going to be adding more information here, and I'm going to base it or organize it around an acronym called ANSWER. And that is from an article that I ran across last summer that I really liked, because it kind of took a lot of different things that I'd already been thinking about and some new things, and sort of drew them all together into a coherent, organized fashion. And it's an article from Faculty Focus by Kevin Yee and Diane Boyd called "How Can We Amplify Student Learning?" So now you know where the word amplify comes from in this segment. So the main title is "How Can We Amplify Student Learning?" Subtitle is "The Answer from Cognitive Psychology." An answer in the article is written in all caps, and the reason is because that's an acronym. And that acronym is one that they propose that we use to help us remember some of these ideas, these widely held ideas and these widely practiced methods of amplifying learning in the classroom, so that when we do those debriefings and reflections, we can pull out that acronym and say, okay, how am I doing on these points here? So what do the letters of the word answer represent? I'll go through that quickly, and then we'll go through each one of those sort of briefly, but I'm going to be giving you definition and some examples that we can use in A&P to implement them. So A is for attention, N is for novelty, S is for spacing, W is for why, W-H-Y, E is for emotions, and R is for repetition. So attention, novelty, spacing, why, emotions, and repetition. And I think if you think about those, you can already think of probably what some of the underlying concepts of those are. But let's take them one at a time. First one, attention. So what we mean by that is, if you're going to be doing some learning, or your students are going to be doing learning, they have to pay attention to the task of learning. That is, they have to have focus. But focus is not the first letter of the word answer, so we're using A for attention. But that's what we mean is focus. And of course, in order for learning to take place, you have to be focused on what is being learned and also on the process of learning, the activity of learning. And boy, this reminds me of a few episodes ago, I was giving different models of homeostasis or analogies of homeostasis that we can use in the classroom. And one of them is what I call the Wallenda model of homeostasis. The Flying Wallendas are a famous group of high wire artists, and they have a certain kind of balance, and we can use some of those principles of balance to apply to homeostasis. And one of the things that Tino Wallenda, who I've spoken to a number of times, he and I were both on the same circus program decades ago, and he knows I use the Wallendas as a model for homeostasis. I was introducing my youngest son to him one time, who had never met Tino, and I said, I'm always repeating your mantra that you gave me when I first met you, and I asked you what the secret is to being such a good high wire artist, and you had told me the secret is practice, practice, practice. And he said, oh yeah. He says, well, I have another one. Speaking to my son, I have another one for you. It's focus, focus, focus. Now you can imagine being a high wire artist that focus is very important. As soon as you get distracted, you might be off that high wire. And that's true for learning too. we want to minimize distractions. So we want to analyze our learning environment. We want to coach our students that their learning environment that they might be in an online course or while they're studying at home or in the library or in their car, wherever they're at work, wherever they're studying, that be something that not have many distractions around. As a matter of fact, I was just listening to a different podcast not long ago, and they were discussing some research that had been done about the distraction of cell phones. And in that research, they found that when you set your cell phone somewhere out visible, like on a desk or a table, while you're working or learning or something that requires attention, if you set that on the table face down so you can't see the screen, and you turn it on silent mode, it's still going to be drawing your attention toward it. You're still going to frequently and consistently be looking at that phone, thinking about that phone, thinking about what might be coming up on that phone. And the effect was not a huge effect. It was a relatively small effect. But they pointed out that a small effect multiplied over a long period of time, a semester's worth of learning, for example, and multiplied by multiple people, either in the workforce or in your classroom, well, maybe that's not so insignificant. Maybe it's worth thinking about. And so, a lot of us struggle with what should our policy be about having devices in the classroom. And I've never had a you must put your devices away policy, but I'm thinking maybe that is the best approach. I do know that when it came time to deciding what kind of clicker, that is student response system, that I wanted to use, which I did long time ago, I opted for a traditional dedicated clicker that the students use that's just for clicking the answers on those occasions when I ask them a clicker question, and not use the device-based systems. That is, the systems that, work through their cell phone or laptop or whatever it is they have. Because my experience up to that point, and it has continued, is that whenever you do that, they're going to get distracted by that tweet that just came up, or checking their social media, or checking their email, or whatever, and now it's going to draw their attention away, sometimes in a very significant way. You might lose them for 5 or 10 minutes at a time as they're texting back and forth with someone else inside or outside of the class. So, we need to think about these things. What are things that are drawing away the attention from the learning task? Another letter in the word answer is N. So we have A for attention, N for novelty. And we know that when we're learning, we know that our brain really wants to have novel, that is new, different experiences. And a lot of the things we've talked about in previous episodes help us do that. For example, I'm always talking about storytelling. That is really relaying the content of our course as if it's a story. That's one aspect of storytelling in our course. Another aspect is telling actual stories. And it can be the story of signal transduction, in the content of that, in the explanation of signal transduction, just as an example. But it could also be an analogy, like using the Wallendas. So I tell stories about the flying Wallendas, and then we tie that into how that relates to how we think about homeostasis and how the body keeps a homeostatic balance in our internal environment. And there's all kinds of other analogies that you and I use in our classroom. And so that introduces novelty, and that helps learning. And there's research that shows that that novelty helps engage the student, and guess what? It helps them focus, right? Because they're not just abstract concepts now. We're listening to a story now. And in a recent episode, I talked about case studies and how case studies, which really are a form of storytelling, right? They're going to engage students. So we can work on case studies, and that will help deepen or amplify learning. Demonstrations. In a past episode, well, again, when I was talking about homeostasis, I use another model besides the Wallenda model. I use the fishbowl model of homeostasis. And I actually do a demonstration. There's a video of it. If you have the A&P Professor app, which you can download from your device's bookstore, then you can go in there and you can see the picture of the little aquarium that I use with the little stuffed animal fish that I put in there when I talk about the fishbowl model of homeostasis. And when I do that demonstration, it helps with focus and it helps with learning because it's a novel experience. It's like, what is he going to do now? And it's kind of silly when I do it and kind of fun when I do it. And so when you make things silly and fun and playful, another topic from a previous episode, when you make things playful, it enhances learning. Doing dissections, that is a novel experience. Even if students have done different kinds of dissections before, like a frog dissected in middle school or something like that, doing another dissection of another specimen, maybe this time a different specimen, maybe a larger mammal, maybe you're dissecting humans in your human body donors in your course. So that's a novel experience. It's sort of, a form of play or playfulness in that we're playing with the parts of the body. Now, I don't mean it in a disrespectful sense, but I mean it in the sense that we're manipulating it, we're going back and forth with it, we're pretending as if we're removing a layer and then putting it back. And so, actually, we're literally doing that, but we're pretending to visualize the body in different ways. And one thing I want to say about this novelty thing is when we start introducing activities into our course beyond what some people would think of as a classical lecture, and I want to get back to that idea of a classical lecture in a moment, but we know that most of us who quote lecture aren't really just standing there reciting facts. I hope that's not all that we're all doing. Instead, we're going to be interspersing it with clicker questions, with just regular old questions to the class, discussions of varying lengths, maybe just a minute or two of a discussion, maybe a whole dedicated 15 minutes of let's get into small groups and discuss. It could be demonstrations, like I just mentioned, could be analogies and playful stories and things like that. All of those things, they are going to not be what a lot of our students are used to in terms of what goes on in a classroom. And they're going to probably most likely feel, the research shows that they usually feel like they haven't learned as much. When you're telling a story and playing with stuffed fish, they're going to walk out of it thinking, well, we didn't learn much today, we just talked about fish. But then later on, they're going to find that the idea of homeostasis is more meaningful to them, and they're going to be able to apply it more easily, but they're not necessarily going to link it back to that story about the fish, that demonstration, that silly demonstration with the fish being stuffed into an aquarium. And so their feeling is inaccurate, generally. When they feel like they've learned well, that's most likely to be high after they walk out of a lecture where you've recited all the facts. And they walk out and think, yeah, I learned a lot there. Now, they're not thinking about the fact that you ask them anything about that a few hours later or the next day, and they're not going to remember any of it. That doesn't occur to them when you're asking them about how much they learned in these different contexts. So keep that in mind. The more novel you make things, the more different kinds of activities you do, the less likely it is, up to a certain point, the less likely it is that your students are going to feel like they've really learned well. And this is reason number 412 why student evaluations of teaching are not worth anything, because you're asking someone who has a distorted view of what has gone on in the classroom what their opinion is. And not only that, but they're untrained as to be able to really accurately analyze for themselves how learning has worked in that course. They don't know enough about the cognitive psychology, that is the learning science behind all of that. So that kind of gets me to I said, I'm going to get to the idea of lecture in a minute. And I think that that's something that we need to look at as a profession, is how we, describe what we're doing in class. Like in most science classes, you're going to have a lecture part of the class and a lab part of the class. And when you use that term lecture for the class, you're thinking of someone standing in front of the room spouting off facts. And you're not thinking of all of the discussion and the demonstrations and the playfulness and the storytelling and all that that's going on in there. So I don't know. I think we need to think about that. I'm not going to do that now because look at all these letters left in the word answer. Let's move to the next one, spacing for the letter S. So A for attention, N for novelty, S for spacing. And I've talked about spacing a lot. As a matter of fact, the very first episode, I talked about spaced retrieval practice. And then in a later episode, when I interviewed the group that calls themselves the Learning Scientists, when they had just come out with a book about most of the things we're talking about today, we talked about spacing. And that is the idea that we need to put a little space in between our learning sessions on any one set of concepts, or even any individual concept. It's sometimes called distributed practice, meaning that we're going to practice with this stuff, but we're going to space it out. We're going to distribute it over different periods of time so that we're going to give at least a few hours before we pick it up again and look at it again and continue our practice with it, continue our focus on it. So maybe if we just practice maybe twice a day, separated by several hours, maybe more than that, but at least give some time for spacing and practice every day rather than cramming it all together. And we know that that's a common technique that students use, is they kind of do a little bit of learning activity and then they leave a really long space and then they try to cram it all in together at the end. And they have to relearn it because they haven't been spacing out their practice. They just did a little practice at the beginning and then left it too long so that the memories really do pretty much disappear. And now they have to relearn it again. So now it's back in their short-term memory again. And then they take the test and then usually off they go. So I've brought up in the past a way to do spacing is something we can do at our end, besides the fact that we're going to, encourage our students to space out their study time and do what we can in the classroom to bring up topics again and again so that, it's spaced, between one class and the next class and the next class. Not only that, but I do cumulative testing, meaning that, they got tested on in this test, but you know what? They're going to be tested on it, at least to some level, in the next test. Even though that's not the focus of the next test, they're still going to get some items relating to the previous test. And then the next one after that, we're just going to add some more concepts to it. And so by the time they get to the final exam, well, they've been kind of building up to that. They already know that it's in their long-term memory. The final exam is going to be easy to them. And how do I know it's going to be easy to them? Because when I started doing those cumulative tests, I found that their performance on the midterm and final exams was better than otherwise. And it's not just my experience. I mean, other people have experienced that as well. So there's a way we can do spacing. And go back to some of the previous episodes. Again, links in the show notes and episode page that'll take you to those episodes. And there were several that I talked about spacing. So we have A for attention, N for novelty, S for spacing. Notice how I'm spacing this out so that we learn the acronym. I'm reviewing it again. So we have A for attention, N for novelty, S for spacing. And the next one is W for Y, W-H-Y. And this gets to the heart of another recent episode where I was talking about transparency in the classroom. And that we should explain to students why we do the things we do in class so they can be partners in that and understand, well, here's why I'm using clickers. Here's what the benefits are in terms of learning science. And here's why I'm doing cumulative testing. Here's what the benefits are in terms of learning science. I'm not doing it to be mean. I'm doing it to be kind because I want you to have this information when you walk out. I don't want you to have wasted all that time and effort and tuition money on or taking out loans that you'll have to pay back someday. I don't want you to have spent all of that and not have anything to show for it. So you're doing cumulative testing. I'm being kind to you. I'm helping you do that. So that's a kind of transparency I focused on in that previous episode. But there's also the transparency I've kind of built into that is a subset of the kinds of transparency we should have in a classroom. And that is, why are we talking about this concept now? Why am I bringing that up? And so we know that the way memories are formed is what cognitive psychologists or learning scientists call associative, meaning that we link memories with other memories. And the more links there are, and the stronger those links are, the easier it's going to be for us to retrieve it later. So that's what long-term memory is, right? Is our ability to retrieve things even in the distant future. And so if we explain to students that I'm bringing this up now because this relates to what we're going to be discussing. Like, here's carbaminohemoglobin again. I'm always bringing that up in class, and some of you know why. If you've been listening to this podcast, I just love saying that word, carbaminohemoglobin. And so, here it is again. Here's carbaminohemoglobin again. And how, what is the context here? Like, I may have brought it up when we're talking about blood and the characteristics of red blood cells and the hemoglobin that's in red blood cells. I might have brought it up there, and now I'm bringing it up again later when I'm distinguishing between the pulmonary circulation and the systemic circulation. And then I'll bring it up again when we're talking about the respiratory system, and not only reviewing the systemic and pulmonary circulations, but also reviewing oh my gosh. You'd think I'd be able to say that without tripping over it as often as I say carbaminohemoglobin. Again, because, that has to do with how the blood gases are being transported in the blood, and that has a lot to do with our story of respiration, the respiratory system. So the why. It's like, why am I going into all of the details of this pathway of signal transduction? Why do we need to know about cyclic AMP, and why do we need to know about this and that, and all these details? I'm going to be a nurse. I don't need to know this. Well, we can give them some of those whys. Like, well, yeah, you do, because this can be helpful to explain how different drugs work, for example. This can explain how other kinds of treatments might work. This might explain how certain diseases develop, the mechanisms of disease, once students get to that point in their studies. So explaining the whys, sometimes, that can take a time out of our course that we can't really afford. But if you just do it a little bit, when you can, and just throw it out there, you give those whys, that's going to make the information more meaningful to students. And therefore, it's going to create connections, going to help them make connections with other things they already know, and that's going to help in their long-term learning. Another angle at this that I want to mention is stopping occasionally to give what I call the big picture. At the end of every system that we cover in our AMP course, I take a few minutes to step back and say, well, how does this fit into the story we've been telling of the human body? And how does this help us maintain homeostasis? So we have a little bit of back and forth, a little bit of discussion. So there's that novelty part. It also is kind of, going back to this why thing of connecting it to what they just learned, and then going back even further and connecting it to what they've learned all the way before that, going all the way back to that initial discussion of homeostasis. So always stop and talk about the big picture. Why is respiration important in the body? How does that help us maintain homeostatic balance in the body, for example? I guess, the last thing I'm going to emphasize there is it all gets back to that storytelling aspect. Isn't it a good idea in storytelling? My wife and I have been watching a very popular mini-series on one of the cable networks it already ended, but we went back and started at the beginning because we had never watched it. And it's one of those cultural events that everybody talks about these characters in this story, and we don't know what they're talking about. So just to be culturally aware, we went back and started this, and we're liking it. But at the beginning of every episode, they kind of review some major important scenes from previous episodes so that we kind of have the backstory. We've remembered that, and we can connect it to what's going to happen in this episode. And then at the end of that episode, then there's always a little summary of some key scenes coming up next. So that kind of, whets our appetite a little bit, but it also is going to help us form connections so that once we see that next episode, we can connect back to that initial experience of it we had in the previews. So, and the other thing that this series does is they'll always have a little discussion embedded in there afterward, where they go back and the writers, producers, directors, and so on will give you some backstory of what's going on. They're talking about how the story is proceeding and what the characters are doing and what that says about those characters. So again, it's giving us the why. It's helping us tie that together. And, if you're watching a miniseries that spans over many seasons. I shouldn't say miniseries, I should say series that spans over many seasons. You're going to need those connections if you want to keep things in your long-term memory. So, man, we better get going because we're using up a lot of time and we're only to E, which is the second last letter of the word answer. So A was for attention, N was for novelty, S is for spacing, W is for why, E is for emotions. And it was going to kind of bring up some ideas I've already mentioned in this segment. Well, number one, emotions that are connected to memories help us retrieve those memories. And if they're positive emotions, such as the playfulness that I've mentioned several times, the curiosity, the joy of discovery, sometimes the silliness, the fun aspect of it, all of that can help with the learning. It can amplify learning. There's a term that I've used quite a bit in previous episodes, gamification, and that's where you kind of, turn learning activities into a game, maybe a competitive game, maybe a game where a student is competing with themselves, basically. If we have that attitude of being playful, of making it a game, of making it fun, then that's it's not just going to make it a more pleasant experience for everyone involved. And that's partly why I started doing it, is like, if I'm going to do this, I'm going to have fun doing it. As a matter of fact, that's an animal training thing that I learned way back from my mentors before I ever set foot in a classroom, is that if you go out there and your goal is to have fun, everything else is just going to follow along. And I think that's true in teaching as well. And that's the way I approach teaching. I love teaching. I have great fun in the classroom. But I also have come to learn that creating an atmosphere of playfulness and having fun and also expressing the joy of discovery. I mean, I will often just stop and marvel at something and say, oh my gosh, that's that second messenger system and signal transduction we just went through. Oh yeah, it's detailed. But look, isn't this great that we have a system like this? Look at why this okay, there's W for why this complexity is so helpful to us. It helps us create greater precision. It gives us opportunities to modify reactions in different circumstances when the reactions probably need to be modified, be amplified or reduced or whatever, or inhibited maybe. And now we have a way to do that because of this complexity here that gives us opportunities to do modification, amplifying or turning down the response. So isn't that amazing? Isn't that great? So, if we can generate that kind of amazingness and not be real reticent and like, oh yeah, it just works this way, but actually get excited about it. I mean, aren't you excited about it? Why are you in this field if you're not excited about it? Of course you're excited about it. So let's express that more. And if we do that, that's going to help with our students. So having a teaching persona that is really positive and really excited and fun and playful, upbeat, I think that helps learning. It amplifies learning. And now we're ready for the R of answer. So we had A for attention, N for novelty, S for spacing, W for is why, E for emotions, and R is repetition. Now, you knew that was coming, right? I mean, I kind of mentioned it several times already, but it gets its own letter. I think it deserves its own letter in this acronym of answer. And the only way that we can really get a memory into our long-term memory is to repeat it again and again and again. So that goes back to that mantra that, I first heard from Tino Wallenda, and of course, my mentors in animal training back when I was back in my circus days. Lots of people use that mantra of practice, practice, practice. And if you've ever been in any of my courses, you know that about me because I make my students say it out loud. I will occasionally test them on it. It's a way to be playful. And I'll say, whenever I ask you, what's the best way to learn something, I want you to answer practice, practice, practice. And then I'll throw it in a few minutes later and say, what's the best way to learn anything? And they'll just look at me and say, oh, come on, And I'll make them say it. And they won't want to say it. But then they'll say it. And, the more you get them to do that and play back with you, the more open they're going to be to other kinds of things you're going to be doing in the course. So you can do that with practice, practice, practice. You could add in the other one that Tino Linda gave me, and that is focus, focus, focus. That's important. So if that works with the story that you're telling in your class, go ahead and use that one too. There's all kinds of things like that you can use. But it emphasizes, in this case, the practice, practice, practice. The idea is that you can't just do a learning activity, walk away, cram, and then expect to do well. Now, maybe you can do okay on the test, but that's going to be short term. What are you going to do on the final? You're going to have to cram again and relearn all that, and it's going to be miserable. And what's even worse is when you get into that next course, let's say you go into a nursing course or a medical course or something like that, and you're expected to remember all this stuff and you don't, oh my gosh, you're going to have to go back and relearn it again. And then maybe again and again and again until you get the idea that you got to keep practicing it. I think here's a case where we have to be very transparent with our students and say, look, repetition is the basic key to all of this. Now, when we do repetition, the frequent repetition that you really need to do outside of class as well as inside class, that involves work. It's effortful. It involves some difficulty as we try to push through, forget it, relearn it, forget it, relearn it, and so on. We have a little bit of space, we forget it a little bit, we refresh it, we forget it a little bit, refresh it. You do that, over time, and eventually becomes permanently part of your memory. It goes into your long-term memory. And sometimes we run into difficulties. It's hard to do that. It's hard to maintain that pace. It's hard to maintain that workload. Sometimes the retrieval practice that we have our students do in applying answers at a higher level thinking skill, that introduces some difficulty, but that's desirable difficulty. And this is another reason why a lot of students feel like they're not learning, because they're struggling so much. They feel like learning should be easy. And learning is never easy. Not if it's really solid learning. It's never easy. It can be fun. It can be playful. But it's never easy. I think that that's an important aspect of repetition that we need to be transparent about and tell our students, look, this is not going to be easy. It's going to be effortful. There's going to be some desirable difficulties, and here's why it's desirable, and explain it to them. My last bit of advice, I know this went way long, but my last bit of advice is that just, if you're going to make changes based on some of what I said or some of the things you find when you explore the links that I'm giving you in the show notes and episode page, just do a little bit and see if it works and tweak it and so on, and then do another little bit another time, another little bit another time. And when you try something new, give it a little bit of time. The first time you try it, sometimes things don't work out so well because, number one, you might not be looking at it really in the best way, in the best light. And you might be working through how to use it effectively, so it's going to be effortful. There's going to be some desirable difficulty. And don't do what our students tend to do and just want to give up. Don't give up. Give it more time and maybe tweak it a little bit and get some advice from some other people. And, if it ends up not working well in your course, it ends up not working well, but give it time to see if it's working well. Okay, way over the amount of time I intended to spend on this topic, so we'll just leave it at that. Hey, don't forget that I always put links in the show notes and at the episode page at the approfessor.org in case you want to further explore any ideas mentioned in this podcast, or if you want to visit our sponsors. And if you listen to the first segment of this episode, now you know what show notes are, right? There are many ways to stay connected to this podcast and to get new episodes as soon as they're released. Just go to the approfessor.org/listen to explore the many ways you can do this. And you're always encouraged to call in with your questions, comments, and ideas at the podcast hotline. That's 1-833-LION-DEN or 1-833-546-6336. Or send a recording or a written message to podcast@theapprofessor.org. You can follow this podcast on Twitter, Facebook, or Instagram using the handle @theapprofessor. I'll see you down the road.
The A&P Professor is hosted by Kevin Patton, professor, blogger, and textbook author in human anatomy and physiology.
After listening to this episode, do not reuse the empty container.